Hey guys, welcome back to my channel. Today I'm doing this video, which is going to comprise of all of the questions that came in June 2024. These are the hardest questions that I came across, like the ones that are high markers. And most of these topics did not come in June 2025 paper one. So it's going to help you in your preparation for the paper two, which is going to happen on Wednesday. So I hope this helps you out. And please leave a comment and let me know if there's something that you don't understand. I'll try to explain it again. So the first question is the algebraic fraction question. Yesterday someone was asking me like how do we identify how to identify expression, like which method to use. So for that I would like to highlight that if you have a three-term quadratic equation like we have over here, you can use either splitting the middle term or you can use the quadratic equation. If you have two square numbers being subtracted, like for example x square minus y square, then we use difference of perfect squares. And if you cannot apply either of these, then you take the highest common factor common and factorize it like that. So these are the three ways in which you will factorize an expression depending on what is given. So going back to our question, we have 21x over 3x squared minus 2x minus 8 minus 7 over x minus 2. And we have to simplify to k over 3x squared minus 2x minus 8. So first, I'll begin with factorizing this quadratic equation. Can you split in the middle term or the quadratic formula, whichever is easier for you. I'm going to use splitting the middle term. For splitting the middle term, we multiply the quotient of x squared with the constant. So that's 3 times 8, which is 24. Then you find factors of 24 and pick that factor, which when added or subtracted give us the middle term, which is 2. So for that, it's going to be 6 times 4 because 6 minus 4 is 2. So keeping that in mind, we're going to replace the negative 2x with negative 6x plus 4x, and everything else remains the same. And this fraction comes as it is. Now we factor by grouping. So we split this equation that we've put into two groups. The first two terms make one group and the last two terms make another group. So in the first group, we have 3x common. That's x minus 2 over here. And in the second group, we have 2 common. And the second group, we have 4 common. So again, x minus 2 over here. Now we take the x minus 2 common. That's going to be 3x plus 4 in the other bracket. So whenever we're adding or subtracting fractions with unlike denominators, we know that we have to make the denominators equal. So to make the denominators equal, I'm going to multiply this fraction by 3x plus 4, both the numerator and the denominator. That's going to be 21x over x minus 2 times 3x plus 4 minus 7 times 3x plus 4 over x minus 2 times 3x plus 4. So that is going to give us negative 21x, negative 28. And since the denominators are same, we can combine it as a single fraction. X minus 2 and 3x plus 4. That's 21x minus 21x minus 28, which shows that negative 28 over here is the value of k. And this x minus 2 times 3x plus 4 is the same as the quadratic equation, so you can rewrite it as this again. So this is exactly as what they wanted in the question. K over the quadratic equation. So k is negative 28. Then the next one is rationalizing the denominator. So this one was a little different than the ones that come in the past paper questions because they're more simpler, even though the method is exactly the same, but it's just that it's a little bit more difficult, very little, not much. So steps, as you know, are still the same. You multiply the fraction by the conjugate of the denominator, which is going to be root 5 plus root 3, and then divide it as well, root 5 plus root 3. Remember, you multiply it and divide the fraction by the denominator, but you change the sign in the middle. So if it's positive, you make it negative. If it's negative, you make it positive. It's 3 root 5 plus root 3 gets multiplied with root 5 plus root 3 over root 5 minus root 3 times root 5 plus root 3. Expand the bracket in the numerator. So that's 3 root 5 times root 5 plus root 3. And then plus root 3 times root 5 plus root 3. In the denominator, we can directly use difference of perfect squares, which is a square minus b square equals to a minus b times a plus b. Over here, they've given the form of a plus b times a minus b. So we just rewrite this as square of root 5 minus square of root 3. So 3 root 5 times root 5 is 3 root 5 squared plus 3 root 5 times root 3 plus root 3 times root 5 plus root 3 squared divided by 5 minus 3. Because when you take the square of a root, it just gives the number inside the root. So that's 5 and 3. Same thing over here. Square of root 5 is going to be 5. Plus 3 root 5 times root 3 is going to be 3 root 15. Because when you're multiplying surds, you just multiply the numbers inside the surds to each other. 3 remains outside as it is. Again, root 15. And then 3. 5 minus 3 is 2. This is 15 plus 3. 3 root 15 plus 1 root 15 is 4 root 15. When you're adding or subtracting surds, remember that the number inside the surd has to be the same. If it's not the same, you cannot add or subtract them. So that's 18 plus 4 root 15 over 2, which equals to 9 plus 2 root 15. That is your final answer. Then the nth term of a quadratic sequence. So an square minus 5n plus c, where a and c are integers. The first 4 terms of the sequence are given. We have to figure out the value of x and y. So if they're given as the nth term, then the first term, which is 2, that's going to be a times 1 square minus 5 times 1 plus c. So 2 equals to a minus 5 plus c. 2 plus 5 equals to a plus c. So 7 equals to a plus c. This is one of the equations that we have, which means that we'll have another one and we can use that equation to solve these two simultaneously to figure out the value of a and c. And once we have that, then we can figure out the value of x and y. So let's use 16 now. So the third term, so a equals to 3 squared minus 5 times 3 plus c. So that's 16 equals to 9a minus 15 plus c, which is going to be 16 plus 15 equals to 9a plus c. That's 31 equals to 9a plus c. That is your second equation. Now we solve them simultaneously. So 7 equals to a plus c. 31 equals to 9a plus c. Subtract the two equations, and that would eliminate c. So 7 minus 31 equals to a minus 8a. 7 minus 31 is negative 24. Oh, sorry, this is 9a. 9a, so that's going to be negative 8a. Negative 24 divided by negative 8 is 3. So a is 3. That means c is going to be 7 minus a, 7 minus 3, and that is 4. Now that we have the value of a and c, we can easily use that to find the value of x and y. So x is the second term. That's going to be 3, which was a, times 2 squared minus 5 times 2 plus 4, which is c. And that is going to give us 6 for x. And y, which is the fourth term, that's going to be 3 times 4 squared minus 5 times 4 plus 4, and that equals to 32. So this is how you find your value of x and y in a quadratic sequence. Then binomial expansion. So it says that in the expansion of 3 plus ax to the power of 5, where a is a non-zero constant, 8 times the quotient of x squared equals to the quotient of x to the power of 4. Work out the possible values of a. If you remember, the binomial expansion formula is NCR times a to the power of n minus r and b to the power of r. This is a and this is b, like the entire ax. So in our case, for quotient of x squared, it's going to be 5c2 times 3 to the power of 5 minus 2 times ax to the power of 2. 5c2 is 10. So 10 times 3 cube is 27 times a square x square, which is 270 a square x square. So 270 a square is your coefficient of x squared. Now for x to the power of 4, it's going to be 5c4 times 3 to the power of 5 minus 4 times ax to the power of 4. 5c4 is 5. So 5 times 3 times a to the power 4 times x to the power 4, which is 15 a to the power of 4 x to the power of 4. Now using the equation given the question, 8 times 270a squared, we don't write the x squared because it says the coefficient, and 15a to the power of 4 on the other side. So 8 times 270 divided by 15, and a to the power 4 divided by a squared over here. So that's going to give us 144. And then we square root both sides, and that's plus minus 12. So these are the possible values of a. And the next question says AB is the tangent to the circle when the equation x minus 3 squared plus y minus 4 squared equals 21 equals 29 at the point 5, 9. Work out the area of triangle AOB. So for the area of triangle AOB, first you need to know that this gives you the coordinates for the center of the circle, and this is your radius. Root of 29 is going to be your radius. Now, this is 3, 4. And if we connect this point with this is your radius. Since AB is the tangent, your radius is always at 90 degrees with the tangent, which means whatever the gradient is of this radius, we can use that to find the gradient of the tangent. And then using this point, we can figure out an equation. And then using that equation, you can figure out what A and B coordinates are, which will further help us in figuring out the area of triangle AOB. So let's start with first finding the gradient of the radius. So gradient of the radius is going to be nine minus 4 over 5 minus 3, which gives us 5 over 2. So since both are perpendicular, the tangent and the radius, M1, which is the gradient of radius, M2, which is the gradient of the tangent, You multiply the two, we get -1. That is the condition for perpendicular lines. So 5 over 2 times m2 equals -1, which means m2 would be -2 over 5. So using this gradient and this 0.59, you will figure out the equation for the line AB. So y minus 9 equals to -2 over 5 times x minus 5. I'm using point slope form. You can use slope intercept as well. Like either we're going to get the same equation. 5y minus 45 equals to -2x plus 10. 5y equals to -2x plus 55. That is your equation. So at A, x is 0. So that means 5y equals to -2 times 0 plus 55 is going to be 5y equals to 55 and y is 11. So this is 11. Then at B, y is 0. So 5 times 0 equals to -2x plus 55. 2x equals to 55 and x is 27.5. So this is 27.5 over here. Write the coordinates, that's 0, 11. So since the x-intercept and y-intercept, that means the distance OA is 11 and OB is 27.5, which means the area is going to be 1 over 2 times 11, which is the height, times the base, which is 27.5. And that gives us a value of 151.25 units square. That is the area of the triangle AOB. In the next question, we have two functions. F of x is 2 minus x over 3 and g of x is 18x squared plus 15x. They're saying that the inverse of f of x plus the composite of g of fx simplifies to ax squared plus bx plus c. Work out the values of a, b, and c. So let's begin with finding the inverse of f of x. First step is that you replace your f of x with y. Right now, y is the subject. We make x the subject of the equation. So cross multiply, swap x with 3y. And now that x is the subject, we replace x with f inverse x and y with x. If you use a different method, that's completely fine. There is no one way to solve an equation. You pick the method that you know better and will save time for you. Now for g of fx, we're going to substitute the function f of x in g of x. So wherever there is x in g of x, you will write the f of x function over there. That's going to look like 18 times 2 minus x over 3 squared. As you can see, I replaced x with f of x plus 15 times 2 minus x over 3. That's going to be 18 times 2 minus x squared over 9 because 3 squared is 9. And this becomes 5 times 2 minus x because 15 divided by 3 is 5. So that's going to be 2 times 2 minus x squared plus 10 minus 5x. Expand the bracket. So that's 4 minus 4x plus x squared. Again, expand the bracket. 8 minus 8x plus 2x squared plus 10 minus 5x. Now we collect the like terms. So 2x squared minus 13x plus 18. So they want us to add the inverse to the composite. So that's going to be, let me take a different color for that. 2 minus 3, 2 minus 3x plus 2x squared minus 13x plus 18. That's going to be 2x squared minus 16x plus 20. This is your final answer. So A is 2, B is negative 16, and C is 20. That's how you solve this. So remember, whatever function is written second, like f of x was written second, so you put that in the function written first. So f of x goes into g of x. If it was f of gx, then g of x goes in f of x. That's how composite functions work. Then for the next question says that a, b, and c are points in a circle. PAC is a straight line. PB is a tangent to the circle. AC equals to BC. We have to prove that x equals to 90 minus 3 over 2y. So first thing, we have x and y for the triangle APB. So this will be 180 minus x minus y, because sum of angles in a triangle is 180. So this is PAB. So 180 minus x minus y. So which means this is going to be CAB. That's going to be 180 minus 180 plus x plus y, which is x plus y. We're subtracting this angle from 180, so that gives us x plus y. Since AC and CB are equal, which means it's also going to be x plus y. But another very important thing you need to remember is that when all three vertices of a triangle are touching the circumference in a circle, we can use the alternate segment theorem over here. And also, alternate segment theorem applies when you have a tangent touching the circle as well. So based on the alternate segment theorem, if this is y, this is also going to be y. So based on the alternate segment theorem, if this is y, this is also going to be y. So now if we add these three angles, which are basically part of a triangle, this would equal to 180. So 180 equals to y plus x plus y, again plus x plus y. So that's going to be 180 equals to 3y plus 2x. We have to make x the subject. So 180 minus 3y equals to 2x. And then divide both sides by 2. So that's 90 minus 3 over 2y equals to x, as shown in the question. So remember your circle theorems. You need to remember like cyclic quadrilateral, the alternate segment theorem, angle at the center is twice the angle at the circumference. Then angles coming from the same segment are equal. All of these you need to be very familiar with them. Then the next question says that here's a graph of y equals to negative x squared plus 3x plus 6 for values of x from negative 2 to 5. So for drawing a suitable straight line, we have to work out approximate solutions to x squared minus 7 over 2x minus 3 equals to 0. So basically what we're going to do is we're going to convert this equation into the equation of the curve. The equation of the curve is y equals to negative x squared plus 3x plus 6. So we need to turn this into this. So x squared minus 7 over 2x minus 3 equals to 0. So first thing, if you notice, the signs are opposite. X squared is positive over here and negative over there. The x term is negative over here and positive over there, and same for the constant. So to begin with, we're going to multiply this by negative 1. So that's going to be negative x squared plus 7 over 2x plus 3 equals to 0. Now that the signs are same and x squared is the same in both the equations, we look at the x term. So that's 7 over 2 over here and 3 over there. So to make it 3, what we can do is we can subtract 1 over 2x from it. Because when you subtract 1 over 2x from it, that gives us 6 over 2, which becomes 3. So it becomes plus 3x as it is in the equation. And what we're going to do is we're going to add negative 1 over 2x over here as well. Because we just don't subtract it from one side, we subtract it from both the sides. Then we need to make the 3 into a 6, so which means we will add 3 on both sides. So that's going to be negative x squared plus 3x plus 6 equals to negative 1 over 2x plus 3. So that means the curve, which is on the left-hand side, is intersecting with the line negative 1 over 2x plus 3. So this is the line that we will sketch on the curve to find suitable solutions for the intersection. So going back to the graph, y equals to negative 1 over 2x plus 3. So we have to sketch the equation. So I have to sketch the graph for this line. If you put y equals to 0, that gives us x equal to negative 3, 6. So x equals to 6 when y is 0. So we have 1 point over here. And if we put x equals to 0, y is going to be 3. So that's over here. If we connect the two intercepts, this is the line that we're getting. And our solutions are negative 0.7 over here and 4.2 over here. These are the values of x that I'm getting. So remember, you have to convert the equation that's given into the equation of the curve. And when you do that, that gives you another equation on the other side of the equal to sign, which will be your equation of the line. And then using that equation, you sketch the line on the grid and see where the curve and the line are intersecting, and that will give you the solution. Then for this question, we have a trigonometric function, and they want us to simplify f of x and hence solve f of x equals to negative root 304 for the values of x between 90 degrees and 180 degrees. You must show your working. So for this, if you look at the numerator, we can see that sine x is common. And the denominator, we have cos x common. So let's factorize it first. So sine x bracket 3 cos x plus sine x. I wouldn't recommend using the identity in the first step because, like, honestly, we don't need to. We need to simplify it. So you using the identity and then, then simplifying it, that's just adding an extra step. So directly simplify it if possible. See if there's the highest common factor between both the terms, which we had in the numerator, that's sine x. And for the denominator, that's cos x. And 4 cos x for that, sorry. So that's going to be 3 cos x plus sine x. Now we can clearly see that there's a 3 cos x plus sine x present in the numerator and denominator, which we can easily cancel out. And that leaves us with sine x over 4 cos x. And we're done with half of the question at this point without even doing an extra word. Now f of x is equal to this, which means sine x over cos x we know is tan x. So tan x over 4 is equal to negative root 3 over 4. So that means tan x is equal to negative root 3. X is going to be tan inverse of negative root 3, which is equal to negative 60 degrees. Now tan is negative in this quadrant and this quadrant. But since they want the values of x from 90 to 180, so we are going to only focus on this value. So x is going to be 180 minus 60, and that's 120. Remember, for the angle, you always start from the positive x-axis. You don't start from the negative x-axis. That's why it's not 60 degrees. It's 120. But we start from over and go till here. So your angle is going to be 120. Then the next question says that matrix M represents a reflection of the line y equals to negative x. Write down the matrix M. So they're probably dealing with the identity matrix, which is 1, 0, 0, 1. So if you reflect this in y equals to negative x, what's going to happen is that you swap your x and y value first. So it becomes 0, 1, 1, 0. So this is negative and this is also negative. Then n is 0, 1, negative 1, 0. Describe geometrically the single transformation represented by n squared. So first we multiply the two. So n squared is going to be 0, negative 1, 1, 0 times 0, negative 1, 1, 0. That's going to give us 0 times 0 is 0, plus 1 times negative 1, so negative 1. 0 times 1 is 0, again 0. Negative 1 times 0, again 0. Negative 1 times 1, negative 1, and 0 times 0. So this is what n squared is. Now if we show this on a grid, we have to describe the single transformation represented by it. So if we look at the identity matrix, initially that's going to be 1, 0, 0, 1. And that is going to negative 1, 0, 0, negative 1. So 1, 0, 0, 1 is going to be 1, 0 is going to be over here. And 0, 1 is going to be over here. So now 1, 0 is becoming negative 1, 0. So that's coming over here. And 0, 1 is becoming 0, negative 1. So this is going into this, and this is going into this. That shows that it's a rotation of 180 degrees about the center or the origin, whatever you want to call it. That's how you solve it. And with that, we're done with these practice questions from June 2024. These were the weirdest ones. And I think some of these topics will come in paper 2 as well. So do go through these and make yourself familiar with the type of questions that can come and the type, like how they can format it and make something very simple sound difficult, even though it isn't. And if you're someone who still haven't checked my predicted paper videos, I'm attaching the link below. There's a predicted paper 1 video and a predicted paper 2 video. Both have topics that will come in your paper 2 on Wednesday. So do check them out. And if you have any questions regarding anything, leave a comment below and I'll try to help you out.